Let's talk about Kubernetes from the security standpoint. And Kubernetes, which name comes from the Greek pilot, and it's all about the analogy of shipping containers in order to have the applications being containerized. Now, it is important to understand that Kubernetes is all about portability, not security, and we'll see how we secure that. But the main intention is, again, to make applications portable. And containers is nothing more than a way of packaging apps so they can run, it can run on any computer environment. You also have probably heard the term DevOps. Again, the idea is to separate the development of an app from the OS version so portability doesn't get affected. The keywords in here are flexibility on that movement of the apps, on that porting of the app, and usability, making sure that things run well when you move them from one computing environment to another. But none of these things are synonym or go together with security, and that's what this small whiteboard is all about. And I don't want you to think that the notion of a container, a closed environment with isolation from one container to another, has anything to do with the analogy of this model. Again, is portability, and we'll see that such isolation does not exist. To represent that better, let's actually draw what happened and compare this with what happens with a virtual machine environment. So in a virtual machine, which was created originally in a way of for allowing the maximum usage of all the resources in a computer environment, memory and CPU and I/O, because if one application, one virtual machine is not using that, then it is available for others. They end up providing a very good isolation from one app to the next, because everyone carries his own guest operating system. So the virtual machine is a Unix, is a Windows. I mean, it comes attached, it comes built with it. Has developed the advantages of being easy to bring up and down, but that strong isolation was, of course, there have been attacks on the hypervisor to compromise one machine to another, but in essence, it is a pretty secure environment. Let's contrast that with the container model. In the container model, notice that the containers do not carry the guest OS. They don't run on a hypervisor, but in a container runtime that provides some very weak isolation between all the resources that the hardware has. And by the way, in case that you are wondering the difference between Docker and Kubernetes, and by the way, some people write Kubernetes as in this way as well. Think of it as Kubernetes being a more modern way of doing containerization like Docker used to do, and also something not only more modern but far more scalable. So it's the way to go. And by the way, but you can also run applications that were run for Docker in Kubernetes as well. But going back to how do you solve the problem of the weak isolation? Well, there are some techniques that are used to improve the situation. So the first one is control groups, and control groups are nothing more than means of making sure that the processes that are running in those containers have some limits on the amount of CPU, RAM, generally I/O, and network resources they can actually have. So you avoid that one container will monopolize all the memory or can grab the memory of another type of process. But in mainly than that, I'm going to talk later about namespaces. This is a way of really making sure that every application, every container image, and by the way, a container image is nothing more than these two things together, that they have a limit to what they can actually access. The next trick to generate some isolation is what is called namespaces. In Unix, number one is the main process ID, and as things get spawned on the machine, you get different process IDs being run, and by default, any process can access any resources. Well, namespaces is a way of actually virtualizing those process IDs. So, for example, in this particular case, this particular container would only have access to these 3 processes and not any other one outside that namespace. The next trick to generate some isolations, to get some security into the picture, is what is called Linux security modules. And there are basically 2. The one that we will talk some more in the future sections of these videos, which is Security Enhanced Linux, or SE Linux, and the other one is AppArmor. This is more for, I've seen this more in Ubuntu, but here is nothing more than, like in other security primitives, is to create some policies that limit the access of different things, and you run those policies on 3 modes. One is what is called permissive. Think of it as in the security world as an IDS, like, I'm going to warn you, I'm going to provide logs when a policy gets actually gets violated. Another mode which is enforced, that actually think of it as an IPS mode. In security, that means I'm not going to let that particular process or that member of that container to perform some of these things that are not part of the policy. And the other one, which is disable, which basically does nothing about it, right? The next trick is, or technique, let's not call it trick, but these things actually will make more the illusion of have isolation between the process, is seccomp. You see, in any system, Linux system, there are about 400 or so system calls, and system calls is the way that you get access to the resources in the system. But a typical program only uses a few of those. Well, seccomp is all about limiting, by design, by policy, what kernel calls can a particular container get access to, what system call can and cannot do, right? And with which argument, etc. And it has actually the capability of killing a process that is trying to go above what is actually permitted to it. So as you see, we are building some isolation, some things that we have naturally on a VM or when applications run native on a particular system. And the way you define this thing is something called Berkeley packet filters. And by the way, that's a technique that has been around for a long time, and this is what TCP dump does. When in the analogy with security, when you do TCP dump, one of the things that you need to do is filter. Say, well, I want to do a TCP dump, but not the whole thing that is going on the network. That's too much noise. I only want to see it coming from this source host and from this particular port, etc. So, and those are expressed also on Berkeley packet filters as well. Now, the problem with all these technologies, and this may vary as different versions of Kubernetes get more into security, is that none of these things, or very few of them, are actually set by default. And that's what makes a Kubernetes environment susceptible to different type of attacks. And again, this, as the developers gets way of incorporating more security without sacrificing too much of the flexibility and usability, then these things may change. But in generally speaking, these things you need to carefully set them by default. Actually, set them because they are not by default. I don't want to give the impression that all is, anti or insecure or against security in the Kubernetes environment. One thing that actually is better is that the container images, these things that we highlight in here, right? These container images are actually read-only. So if any one of these is attempted to be changed, you actually get a security alert right away. Okay, so this is like when you want to have a system that is very, very secure. If you want to do your banking transactions, you may actually run those from a CD or a DVD that boots in it, so to make sure that no virus can actually get into the CD image because it's read-only. But the same thing you get with container. That's actually a good thing. Another thing that is very positive about this Kubernetes model is that the actual container images, they live in a container registry. And from it is that you deploy them and put them into production. And these are things that are meant to be, lasting 1 week or so and have multiple instances of it. And the system makes sure that if one dies, then another one gets actually spawned automatically and all those good things. But again, because those container images reside before they run in a registry, well, patching is something very nice because you can scan them at will without impacting any performance. You don't have to wait until the weekend to run your scan. You can actually scan them constantly. As you get new notice of a new vulnerability being announced, you can scan your system for it. And also you can patch in the registry as often as you want because this doesn't impact performance, because in the registry the things are not running. But then whenever your short-lived container, the application in the container dies and a new one gets spun out, well, that one is going to be actually fully patched. So not everything is harder in the Kubernetes model. Again, these two things are two positive aspects. But what we will be doing in the next videos is actually attacking some Kubernetes infrastructure and see how you should set your system and your curator system to detect those particular attacks.